Welcome everyone to the week 3 tutorial session. I am Brati Ludani, pursuing PhD at Department of Mathematics, IIT Bombay. I am a PMRF fellow here. Today we are going to discuss assignment of week 3. Last time we discussed some sample questions related to formal power series from week 3. So we'll skip 2 questions and we start from question number 3. So let's begin. A formal power series fx has a multiplicative inverse in f double bracket x if and only if f dash x is invertible. So this is a true false question. So let's check if this happens or not. So consider this fx from this. Now this has a multiplicative inverse implies so you know that if this has a multiplicative inverse, this implies a0 is equal to 0 is not equal to 0. So if you write fx to be where fx is an x raised to power n. Okay, so this is the condition, you know. Now at this place let's check if this condition holds, then f dash x is invertible or not. So first thing is, what is f dash x? This is something of the form, so yeah, so this is like a0 an x raised to power n is equal to 0 to infinity, and you are basically multiplying with n is equal to 0 to infinity. Now what happens here? We'll get this, right? This differentiation f dash x is what? F dash x is this expression. So this implies you have constant term to be what? Now okay, so if I want to write in a better way, what I can do, I can just start with for example, I'll write x raised to power n, here an plus 1, here n plus 1, and here what I can write, I'm just doing plus 1, I'm replacing n by n plus 1. So here also I should do that, n by n plus 1. That means, so one more thing, okay, before going there, that will be easy if you want. You'll have this n is equal to 0 to infinity an x raised to power n. Now if n is equal to 0, this expression is itself 0. So we may write, okay, now you do that trick to balance. Basically anyway you know how to do product, but it's better to write for the differentiation thing, that can be done easily. So yeah, so here you start with 0. Now n has been replaced by n plus 1, so you got this. Now in this situation, x raised to power n, so we are searching for the so I can write the expanded form. And here you will get a1 plus a2x square, here you will get 2a2x plus 3a3x square plus up to and so on. So now as a constant term, what you will get? a0 a1 plus for x1 what will we get? a1 square plus and other side you will get 2a1 a2, sorry, not a1 a2, it's 2a0 a2, and this will be a coefficient of x. So this is the thing you got. A0 a1 is your constant term. Now so for invertible thing we should have constant term to be 0, so constant term to be non-zero. So let's see, now fx is invertible, then a0 is not equal to 0. So here a0 is not equal to 0. But what is the guarantee about a1? a1 could be 0, that there is no condition on a1 from fx to be invertible thing. So if a1 is equal to 0, then or I can write, if a0 is not equal to 0 and a1 is equal to 0, then fx is invertible, but f dash x is not, and that proves that this is a false statement. Very good. Yeah. Okay. So if you want some example, we can definitely construct it. Just take some fx to be 1 plus 2x square, or maybe if you want to write x square plus, just doing random. So if you consider this f, then f dash x is not invertible. So we have a counter example. Okay, I hope this is clear. Let's move to the next question. So here fx is given to be, again from the formal power series, which satisfies this condition, f dash x plus fx is equal to summation n is equal to 1 to infinity minus 1 raised to power n plus 1 and x raised to power n, and f0 is equal to 1. Then what will be your fx? That is the question. Okay, let's see what happens in this situation. So again, assume fx, so you need to just solve this equation. So assume fx to be summation an x raised to power n is equal to 0 to infinity. Then as we done earlier, this should be n plus 1 an plus 1 x raised to power n. Okay, is that correct? We can check. So if you put n to be 0, then you will get 1, and here n to be 0, so we have a1, right? This is okay. Okay, so yeah, now let's apply these two things in this equation. So you will get f dash x plus fx is equal to summation n is equal to 1 to infinity minus 1 raised to power n plus 1 and x raised to power n. So when we can add also, so I'll just write like this. Okay, so now this implies an plus n plus 1 is equal to minus 1 raised to power n plus 1. After comparing on comparing coefficients of x raised to power I. The powers, or maybe we can write x raised to power n. Now this implies, so we have this for all n belongs to n. So here again n is from 0. Okay, so which means, so now what everything we have f0 is equal to 1. So let's consider that f0 is equal to 1. First thing, so we have f0 is equal to 1. That means, what is f0? F0 is just a0. Just put 0 everywhere in this expression. So a0 is equal to 1. Next, what do we have? So this is a recursive relation. So we'll get a1, so we can apply a0. So and for n this, or maybe okay, I can write this. For n is equal to 0, we'll get a0 plus a1 is equal to minus 1 raised to power 1. So that is just minus 1. And n is equal to 0, this is just 0. So this implies a1 is equal to, a0 is 1, so a1 is equal to minus 1. Now for n is equal to 1, we'll get a1 plus 2a2 is equal to minus 1 raised to power 2. So this is just 1, and n is equal to 1. So this implies a2 is equal to 1 plus 1 by 2, which is just 1. And now for n is equal to 2, this will be a2 plus 3a3 is equal to, again, minus 1 raised to power 3. So we'll get minus, and n is equal to 2, we'll get this. Now a3 is equal to minus 2, a2 is just 1, so this will be minus 3 by 3, this is minus 1. So can you observe this pattern? So we will go on. So they just alternate. So 1 minus 1 1 minus 1. So fx is basically, so why this is happening? So there are this term and this term. So you are getting a and to be something. So if you want to write, so the observation is like, so this is an plus 1. An is your, so an plus n plus 1, an plus 1 is equal to minus 1 raised to power n plus 1 n. So this value is going to be this into, so this is just 1. So I can write just this value. So an is going to be this, and because of this, when you take it here, you will get minus 1 raised to power n plus 1 n plus 1. And when you divide by this, you will get just minus 1 raised to power n plus 1. So this is the process. This implies fx is equal to summation anx. So what is your an? So maybe I write an is equal to minus 1 raised to power n for all n belongs to n. Okay. This fx is equal to summation n is equal to 0 to infinity minus 1 raised to power n x raised to power n, and we are done. So let's see if that is an option. So this is this. Okay, great. Let's move to the next question. True or false? So it is given that let U and W. So let U and W be two primitive words such that U is not equal to W. Okay, so what does that mean? So U and V be two. So what is a primitive word? So a word U is said to be primitive if U is equal to W raised to power D implies, let's write V just so you will not get confused with this W. So a word U is said to be primitive if U is equal to V raised to power D implies D is equal to 1. So basically there is no repetition. So repetition of a proper set. So for example, AB can be written as AB2. So this is not primitive because there has been a repetition. Next, so if you consider, let's say ABA or maybe BA, I just put A now. There is no one part of it which is being repeating. So this is primitive because you cannot write it as B raised to power D where D is bigger than 1. So that is the case. Okay, so I hope this is clear, the definition. Now they are asking if you have U and W which are primitive elements, primitive words, then what can you say about UW? So UW is just we are writing it together. So for example, if your U is for example ABA or so for example you have this U, so okay, UW, so what is that? For example, if U is equal to AB and W is equal to, let's say again AB, then UW is equal to I gave an example.
उसको कौन सुनाई देगा? और अपना वीडियो कैसे बंद करते हैं बताइए? ऐसा बच्चा लोग सभी लड़की है पढ़ने वाली, बात करें इससे
So if U is equal to AB and W is equal to AB, concatenate at the end of u. Okay, so okay, so this is uw. So you can have something like, let's say this, then you will have this, you can have anything. So as you can see, I gave one example, not example, just the for this statement, is that true or false, I gave a counter example, so to say. So if you take u to be yeah, not counter example, sorry. So one thing is, u is given to be ab, and they have said that these are two primitive words which are not equal. So if u is equal to ab and w is equal to ab, then certainly uw is just ab ab. Okay, so this implies which is not primitive, right? But they have said that v is not equal to w. So this is a condition they have imposed, because this is trivially there. So let's see if we have an example. So you take, so you don't want anything to be repeated here, anything to be repeated here. So let's take a b a, and here you take a b, then these are both primitive. Then uw, so what do you have then? Uw will be ab ab, which is equal to ab. So this is not primitive, and certainly u is not equal to w. So we have a counter example, and this statement is a false statement. Okay, I hope this is clear. Okay, let's move to the next question. Which of the following size functions give a combinatorial class structure on the set of positive integers? So let's take so you have, so what is a combinatorial class? This is a set A with some size function where which satisfies the following properties. So this size function is what? Size function is going from a to n. So any element of a is mapping to something, and we write it like this. So you have a, you will write it like this. So this combinatorial class satisfies the following properties. First, this a is finite or countably infinite, cannot be uncountable. And the other property is, you take the set, we write it an, the set an which is of the elements alpha from a such that size of alpha is equal to n, this set is finite. So the number of elements whose size is a particular number, let's say n, then so that set is finite. So number of elements are finite which have size n. Okay, so this is true for all n belongs to n. Okay, so this is the definition. So now you have given to be a p as a, so set of positive integers. So this is just the set 1 2 3 4 2 and so on, and size is given to be this. So for the first step, or yeah, so you have this. So first is size of n is equal to summation d divides n d. This is what? This is so this is the size. Okay, so that might be confusing. Let's write n for simplicity. So you write n m here, because this, otherwise this will be confusing at this step. So now you check one more thing. This is countably infinite. So first property holds. So first is okay. Now let's check the second condition. So you have am, which is the set of all alpha from a, and a is your p. Then cardinality, so size of alpha is equal to m. So now let's see what do you have. So at this step, what is happening? So d divides n. So okay, so this is what, this is the sum of all the divisors of n. Now what can you say about this? That is the first question. So you have some number. So let's observe what is happening. If you take 1, you'll get 1. When you will take 2, so d could be 1 and 2, so you have 1 plus 2. Here when you will take 3, you'll get 1 plus 3, because 1 is a divisor and 3 is a divisor. And you take for example 4, you'll get 1 plus 2 plus 4, and so the sum, this is the sum of all the divisors. Now you can see that this is a increasing thing. So when you, because there is this biggest number is always there. So when you go ahead, when you take the numbers 1 2, these numbers are anyway going to be there. So this is an increasing sequence. So for every number, so this implies, so my claim is am is equal to is either 0 or 1. There is nothing in between, so nothing after that. So because when you take 2, so whenever you go ahead, you will always get this biggest number, which is n. So this is always something n plus. So when you take cardinality of n, this will be always n plus something. So this is going to be bigger and bigger. Or okay, I think this is not a right path, because there is a possibility of, for example, you have so for example you have 5, you will get 1 plus 5. And for example, when you have something lesser, so what is my point? So if you take 7, you will get 1 plus 7, and 4 you got, and what about 6 you will get 1 plus 2 plus 3 plus 6. So this is definitely bigger than, cardinality of 7 is definitely bigger than 6, right? So sorry, the other way around. So this is bigger, so this is not an increasing sequence, not increasing, always not increasing, my bad. So I cannot say this now. So what is the point? You can have something, for example, when you go to 11, that is just 1 plus 11, and when you have something like, let's say not 10, 10 is very near, so let's say you have even not 8, for example 6, what have you got? This, so you got 12, right? 6 plus 5 plus 1, so you got 12, and you got 12 here also. So size of 6 is same as size of 11. So yeah, that is a task. Now what can you say about how many numbers are going to be there in this part? So what will be your AM for yes, for example A11, sorry, not A11, A12 is bigger than 2, so it's bigger than or equal to 2. Okay, so at least you have 6 and 11 to have size to be equal to 12. So so let's just try it out. Whether whether the size function is not size function, whether the second property holds. Okay, just try it out like this. What can you get? Okay, we'll discuss next time if you didn't get it. Okay, what about the next part? So you have to, so n is equal to, we'll get an idea if we need the other parts. So you have this. Now d is not equal to n. So d is not equal to n, that means now the difference is just d is not equal to n. So for example, if you take prime numbers, let n be a prime number, then what will happen? You'll take this will be just, you have divisors of n, which will be what? N is prime, then the only divisor, and d is not equal to n, so the only divisor is just 1, so you'll have 1. So for all the prime numbers, what I was writing, yeah, for all the prime numbers, cardinality of, for all the prime numbers n, this is equal to 1. This implies am is equal to, which is all the alpha belongs to P such that cardinality of alpha is equal to 1. Let's take just 1. This is not finite, so there are many numbers which has size to be 1, is finite, is infinite. Okay, let's see what about the third part. So this is not a combinatorial class. Okay, what about the third part? Summation d divides n, d is prime. Now the condition is d is prime. So d is prime, what does that mean? You take so here let's take what, so let's take what could be a possibility. So when they said d is prime, then you just take powers of some element, so powers of some number. So for example, you take 2 raised to power 1, what will you get? Summation sorry, D divides N and D is prime. D, what does that mean? N is your 2, so that means you have just 1 and 2 as your elements, and prime is just 2, so 1 is not a prime number, so you'll just get 2. Okay, and when you take 2 raised to power 2, you will again do this thing, and D is prime again. So now you have the divisors to be what? 1, 2 and 2 square. The only prime number is just 2, so you'll get 2 again. So for every every number of the form 2 raised to power k, the size is going to be summation size is going to be 2. So now how many numbers you have? These are k, could be anything, so this implies the set you have to all those alpha belongs to A such that and I can write A2 here, and you have the numbers this is infinite. Now similarly for powers of 3 you will get 3, any power of b you will get b. So this such sets are going to be infinite, and that's why this is not a combinatorial class. Okay, let's move to the next part. Okay, I'm writing in numbers, not Roman. So this is your fourth. What does this say? Summation d is from 1 to n d. So cardinality of n, so size of n, sorry, this is something which we usually use, cardinality word. So anyway, so size of n is equal to summation d, where d is from 1 to n. So you will have what here? So d is from 1 to n, that means, for example, if you have 1, then you will get 1. When you have 2, you will get 1 plus 2. When you have 3, you will get 1 plus 2 plus 3, and so on. So what you are getting, you are actually getting 1. 2 plus 1 is basically 2, so it's 3, but so I'm using n plus 1 by 2 formula, so this is just 2 into 3 by 2, which is 3, and similarly 3 into 4 by 2, which is 6, and even you can write this is what? This is your n plus 1 choose 2 also, so you can write in any form. But as you can see, this is something which is increasing, so this is increasing for sure, not the first part. Okay, I'll include the solution of first part in the notes of the tutorial, so you can check it there if you didn't get it. Okay, so here, yeah, this is increasing. Now you'll get yeah, so this is increasing for sure. So this implies A2 or sorry AM is going to be AM will be 0 or 1 only. Better way to write can only be 0 or 1. This implies this is a combinatorial class for all m belongs to n. So it implies this is a combinatorial class. Okay, so this is the thing. Now let's move to the next question. Okay, so yeah, just a second. Yeah, so you have now solution. So now what has been given, so this is your neutral class, if I'm not wrong, and this is what we say this to be. This is yeah, so this is a neutral class and this is an atomic class. Okay, so and what does this say? This is neutral class with size to be 0 and the size of this element is 1. Okay, so this is the usual terminology. So for every combinatorial class, which of the following is true? So you have now what is happening, we are doing sums and multiplication on the classes. So you have a plus epsilon. So what does that mean? Firstly, let's see. So for isomorphism, so okay, there are so many terms so you can check the notes for that, but I'll just go quick on this. So a plus epsilon is what? A plus epsilon is so what you are doing, the class is, yeah, so I'll write this symbol, that is a better one. So you have this is what elements are you have. So this is a usual way to write it. So the set is A disjoint union epsilon. So if there is a repetition between A and epsilon, then we'll consider it different only. So those are two different elements. So so you have this, and for any alpha in A plus epsilon, this will be alpha of A if alpha belongs to A, and this will be just 0, which is epsilon, if alpha is equal to epsilon. Okay, so this means that now is this isomorphic to A? Firstly, for what is an isomorphism? Isomorphism means, so A is isomorphic to B if there's a bijection plus any, so there's a sigma which is mapping A to B, then size of alpha is same as size of sigma of alpha. Okay, for all alpha belongs to A. Okay, so these are two conditions which is required for an isomorphism. So now let's see so firstly check how many elements we have. So there should be a bijection. Now you have here A plus epsilon. So you have, for example, if A is finite, then there is no bijection, because if A is finite, then A plus epsilon and A have two different like, so there's this difference. Yeah, So there is no bijection if A is finite. Then you have number of elements to be, for example, finiteness. So cardinality of A plus 1, and you have just cardinality of A. So now if this is infinite, then what can happen if A is infinite? If A is infinite, then no, if A is infinite, then there is a possibility. Then you can define a bijection. There could be a bijection. Okay. Now if there is a bijection, so there is something like when you have, for example, P. So you have A to be P. Then you add, for example, this epsilon. Then what will you do? So epsilon, and you have some epsilon plus P, and here you have just P. So you have these many elements. So one is, you cannot map all the elements of P to the same element of P. Here what you need to do, you have to settle epsilon also. So for example, what will you get? You have 1 plus, sorry, not 1 plus. So where can epsilon go? Epsilon, let's say if it goes to 1, so and just deducing how can you get a bijection? So epsilon is going to 1, so 1 is going to 2, and so on. So but what will happen now? This is a combinatorial class. Okay, so okay, shall I say, now what do we have? So there could be a bijection firstly. Okay, that is one thing. The third thing is this, so whatever you map to anything, that should satisfy this property, right? That should satisfy this property. So let's see what can we do. So we don't know, yeah, okay, okay. So one thing is there, shall I say, so you know that AMs are finite. Okay, for example, if I give you an example, all the elements are mapping to 0, like for all n this is equal to 0, let's say. Okay, for all n belongs to n, so for all n belongs to n, this is equal to 0, then this is okay, because when you take epsilon, then the size is 0. When you have anything else, that is also 0. So there is no problem, because there is a bijection and all the elements have size 0. Then there is no problem. But you know that you are in this is not the case, because AMs are finite. This is a combinatorial class. Okay, this is a combinatorial class, so you cannot have such property. So what is happening, if epsilon we know has to go to 0. Okay, has to go to 0. Now you know that, now let's see here, sorry, why shall I, so let epsilon goes to somewhere, some element alpha, where alpha belongs to A. Let sigma of, not sigma, now to hold this property, to satisfy this should have, for simplicity let's write A, it will not get confused. So you have this, to satisfy this we have size of this is equal to size of this, which should be 0. Okay, so you know that this should be 0. Now we know that A0 is finite, which is all the elements which have all the elements of A which have size to be 0. Okay, so what will you get here? So you have size to be 0. Now at this place you have a bijection. So A0, what will you get? A0 to be so for A plus epsilon 0 will be A0 plus 1, because there is one more element which is mapping to 0. That is clear. So, and this is finite. So this implies this is finite, or you just say this is finite. So this cardinality is not going to be same as cardinality of A0, and there it will fail, because you have this element you have n many elements which are of size 0 and n plus 1 elements which are of size 0 in A plus epsilon, and that will make sure that you will not get this value. So this implies we cannot have sigma of alpha is equal to like sizes. Okay, we cannot have this because of this property, because there are not equal number of elements. So you have here for size 0 you have A0 plus 1 elements of size 1, you have sigma, I started with A plus epsilon, so here you have A0 plus 1 elements whose value size is 0, and you have A0 elements of size 0. Hello Abhinash. Are you here to discuss questions?
No, I am here for classes, Combinatorics.
Okay, you joined earlier and I couldn't understand if you are really joined for this. Okay, that's okay. So have you tried this week 3 assignment?
No, sorry, this is my first class.
Okay, so no, but anyway you are uploading assignments, right? Because you're submitting assignments, right? So week 3 you must have done. Okay, anyway, like have you gone through the lecture notes?
No, just I joined.
Yeah, but the lecture notes, you first discuss like you study lecture notes and then you try questions. That's why I'm asking, but that's okay. So
from where I get lecture notes?
Sorry?
From where I get lecture notes?
Yeah, because lecture notes are a requirement to understand the terminology. But anyway, like if you're familiar with it, then well and good. It is dark here, so I'll just turn my camera off. Already it is dark. So anyway, so I was just discussing this question. So epsilon, so there are two classes, neutral class and atomic class, so which have this property. Are you familiar with it?
Um, I not familiar, but we know. I know this fractional part and modulus.
Sorry. So this is a question related to combinatorial class. Are you familiar with combinatorial class?
Yes, yes.
Okay. So do you know the definition?
Combinatoric class for every combinatoric class of which of the following is. No,
Sorry.
madam, I know class.
Uh, which
Yes,
class?
for example, equivalence class. But I
Okay.
heard first time. This is combinatorical class.
Okay. This is actually in week three. Week three lecture notes. So you can check it and read it. So this is really. So this is for every combinatorial class. So okay, so maybe I'll complete this question, and from next question, you you might ask me, like I'll discuss the definitions also. So I'll just complete this question first. Is that okay? Will that be okay? Okay. Anyway, so what I was discussing. So yeah, first part is done. So we cannot have this isomorphism. So this is not true. Now what about A cross epsilon isomorphic to A? So basically, if you okay, what is a combinatorial class? Combinatorial class is this. So if you have a set A with some size function. So there is a function which is defined on A, which maps every element of A to some element so this is a set of natural numbers which start with 0. So this is actually set of non-negative integers from the terminology we are using, so notations we are using. Okay, so you have n to be 0, 1, 2 up to and so on, and you have this set A. So combinatorial class is a pair A comma size function which satisfy the following properties. So A should be finite or countably infinite. Okay, so there are two options. It could be finite or countably infinite. So it cannot have uncountable elements. So for example, you cannot take A to be real number set. Okay,
Okay.
and yeah, and second property says so size function is like so you have this function a to n which maps all the elements to some number. So here if you pick some number, for example, let's take you take 0. So you take for example 0. So what is a0? A0 is all those alpha from this set A such that size of alpha is equal to 0. So you have size of alpha to be 0. Okay, so that is a0. You can have many elements which are mapping to just 0. Okay, so you will have this set to be something which have some elements. Then this is finite. So if this set is finite for all m, so I just wrote for just 0, you can have 1. So basically number of elements which are mapping to a particular element, particular number, if that set is finite, so number of element, if that number of elements is a finite number, then you will say that this is a combinatorial class. So for example, if you have I'll just write some example. Okay, maybe here. So for example, a is given to be some set of positive integers. P denotes set of positive integers. Okay, so you have for example 1, 2, 3 up to and so on. Now what does this say? This says that, so for example, I just define the size function to be for all alpha belongs to p. uh, can you unmute your sorry, can you mute your speaker? So yeah, for all alpha belongs to p, cardinality, so size of alpha is equal to, let's say there's some number, let's say some number to be equal to yeah, d, let's say d. Okay, so I'm saying for some fixed number d. Okay, d belongs to n. So I'm saying I'll map all the elements of p, 1 2 3 4, all the elements to, so this is the size function, to 0. So all of them have size to be d, not 0. I took d here. So all the elements are mapping to d. So when you take AD says what? All the elements of p, so A is your p, such that cardinality of so size of alpha to be equal to d. Now you know that all the elements are mapping to d, so this set is full set p, right? So, and this is infinite, so this is not a combinatorial class. Okay, this is one example. Here note that if you take am where m is not equal to d, then this is going to be just 0, because there are no elements which are mapping to 0, sorry, which are mapping to other elements than d. So if you take any other elements, let's say d plus 1, then there is no number, no positive integer mapping to that element d plus 1. So you have for all the other elements you have this, and for AD you have the full set. Okay, but this is infinite, so this cannot be a combinatorial class. Okay, that is the catch here. I hope this is clear. You can ask if you have any doubt. Avinash?
Okay, madam.
Okay, so this is the definition of combinatorial class. Now let's move to, okay, so what we were discussing. So here you have so I'll do this question first, because there is more preliminaries you need. So these are some combinatorial classes. Now let's see. So this cannot be an isomorphism. Now what about this isomorphism? A cross epsilon, isomorphic to A. Firstly, let's check what are the number of elements we are having. So you have pairs. For cross you have pairs. So this is something from the node. So what is a isomorphism class? And also I discussed earlier while explaining the first part. So cross is the set of all the pairs. So you have A cross epsilon. So the element of this set epsilon is just this epsilon, which has size to be 0. So you have this. Now you can map all the elements to this. Okay, so you can do this for all A belongs to A. So you have a isomorphism, so you have a bijection. Okay, this will make a bijection, this will form a bijection. So you have a bijection. Now what about size function? So for isomorphism, what we need for a isomorphism, I can change colors. So for an isomorphism you need these two conditions. There should be a bijection, and the size function of the element of the image of that element should be same. So you should have those two things. Now let's see what do we have. You know that size of A plus epsilon is what? Size of A plus epsilon is sorry, not A plus epsilon, this is A comma epsilon. So yeah, this is what? This is what do we say, like a, so this is a pair, so you should have size to be, if I'm not wrong, it should be multiple, this should be plus, right? So this size to be, the size should be this. So if we write it like this, so here size will be what, a plus 1. Now there is yeah, sorry, not plus 1, this is just 0, because you know that epsilon has this 0. So this can work because you have a bijection. Now the sizes are same, this is from a cross epsilon. So these two things are there, bijection is there, and the sizes are same of the image, like of the element and the image. So this is true, a cross epsilon is the required one, so this is true. Now you can check for the other two, similarly, exactly same, you just try if you can define a function or not. Okay, so yeah, just try it out and check whether these two will be okay or not. So yeah, homework, do the similar work. Okay, yeah, now yeah, so for such questions, basically you need to check what everything you need. So you should, can you define a bijection, can you define a map which, so in this bijection can you satisfy this property, and you can check it. So I discussed first question, and you can try it. I'll upload on YouTube definitely, so you can check for the first part and can try C and D. Okay, Avinash? I hope this is clear. Okay, so yeah, let's move to the next question. I think that will help, because that so anyway, so you have primitive words, alphabet and letters. So yeah, what is a primitive word? Please go through the lecture notes, that will help you, and if you have any doubt you can ask me. Okay, so what is a primitive word? Primitive word is if you have something like okay, I wrote it earlier also. So a word is said to be primitive if yeah, so if u is equal to, sorry, if w is equal to u raised to power d, then d is equal to 1. So what does this say? This says that so for example, if you have binary words, okay, you are in the set of binary words. So you consider this set. Now what can you see here? So for example, if you have this 1010 as your w, so you can have any number of chain, okay, like any number of elements in the chain. So length could be anything, and alphabet says so for example, here we are in binary. So binary means we are in 0-1 set. So when you say alphabet set is of 3 letters, you can take A, B, C, you can take 1, 2, 3, you can take 0, 1, 2, it doesn't matter, you just take any 3. So these are 3 letters alphabet. Okay, so you have this. Now you have W to be 1010. So for example, you can have W to be 101010. So length we can restrict, but this set is something which is in general. You can write it with W, for example, or you can write it binary if you want. So let's write B. So set of binary words. So if you take W to be 1010, then you can write it 10 square. Like there is a repetition of 10. Then this is not a primitive element, because it says D should be equal to 1. If you write W to be, you cannot write it as the you this W should not be a repetition of element. You can have this, for example. Here you cannot write it like this. For this you have to write this, but this is not something which we need. We need U raised to power something. So you cannot have something other than after that. So this is a primitive element. This is a primitive element. Okay. Do you understand the definition now, Avinash?
Okay, madam.
Yeah, so the definition, so this is the definition now. Okay, so now it has been asked. So you have the length to be, so length is 5. So you have 3 letters. Let's say if you want to discuss, let's say ABC. You write it ABC. You have alphabet set to be this is alphabet set, and length is given to be 5. So you will be having in the set, for example, A B C A B A B A B C, or so you can have something like this. Okay, you can have also you can have, for example, A. Now here you can see, you can write it A raised to power 5. So this is not a primitive word. Okay, so you have to count all the primitive words, not a primitive word. Okay, so there is a formula to do that. If you check the notes, you can do that, which uses a theorem which says that any element you can any word you can write it as some power of a primitive word. So using this and Mobius inversion, you can actually get primitive 5 is equal to summation. You will have k raised to power I think D mu 5 by D, and D should divide 5. So this is the formula where k is something, k is 3. So you can check the notes. Okay, so here what are all the elements for D? You have 1 or 5. So you will have 5 by 1, 3 raised to power 1 plus 5 by 5, 3 raised to power 5. So you'll get mu 5 into 3 plus mu 1 into 3 raised to power 5. And what is mu 5? That is a prime number. You'll get minus 1 into 3 plus n mu 1. So this is Mobius function. So you have 1 into 3 raised to power 5. And that is, this is 243. This is minus 3. So you'll get 240. So this is your answer. Answer is 240. Okay. Okay, let's move to the next question. Find the number of necklaces of length 5 in an alphabet set with 3 letters. So you have the same thing. Now what are necklaces? Necklaces says you should not have cycles. The cycles will be considered same. So for example, you have 5 letters. You have 1, 2, 3, 4, 5. So if you have A, B, C, for example, A, B, C, then this is same as C, A, B. So you take C to be in front, then you will have C, A, B. You just need to move. So these are the same words. Next, for example, you can write, for example, B, C, A, B, A. You can take B to be in the first place. So any cycle, so this is a cycle form. So all the elements in this cycle will be same, will be considered as one element. Okay. So we use equivalence class, as you know that what is an equivalence class. So you will go mod, so you have all the elements. So you have 5 letters, so you have all the possibilities are, and with 3 elements, so the possibilities are 5 raised to power 3. So you'll get an equivalence class is something cycles. Okay, so cycles are considered to be same. Okay, so this is a necklace. So necklace is a set of this kind. So again there's a formula to do that. You can check the notes, which says necklace of 5, so length is 5, this is equal to some primitive of d, and there's a coefficient on it with I think you can actually prove it, that is easy. So it should be, I guess, primitive d by d. Okay, and this is d divides n. So you'll have this. Okay, sorry for the disturbance. Okay, where were we? So necklace of length 5 in an alphabet set with 3 letters. This is the formula. So let's calculate. This will be what? Primitive number of primitive words with the length to be 1. So because what are the divisors? Divisors are 1 and 5. Because n is 5. So we'll get 1 plus. Okay, so now what is this value? So according to the formula, you know that this should be d divides 1 such that mu n by d is, so you have 1 by d, and you have k raised to power d, and here d is equal to what is it? D is just 1 because that is the only possibility. So you have mu 1 and you have k is what? K is the set, k is the letter number of letters. So this is 3 and you have 3 raised to power d, so this should be 3 and you should have 1. So what is mu 1? Mu 1 is just 1 and 3 raised to 1 is 3. So you have 3 plus what is this value? This is 240. So 240 by 5, so you'll get 3 plus 48, and this should be 51. So that is your answer. Okay, let's move to the next question. So let a is equal to 1, 2, 3 be the combinatorial class with size function. So you have size function to be this, then sequence of sequence ax is equal to, so what is sequence a, what is this? This is actually this neutral class plus a. So actually I'm writing with a terminology. So this is a square plus up to and so on. Now this is your sequence class. Now what is from the formula, what do you know? So this is what? This is 1 by 1 minus ax. You can check the notes. So your generating function for sequence class is 1 by 1 minus sequence class generating function of a. Now so what is this? So we should know what is this. So ax should be what? Now you have 1, 2, 3 as your set A, and cardinality, sorry for that. So you have size function to be equal to the same value. So 1, for 1 you will get 1, for 2 you will get 2, for 3 you will get 3. Okay. So now when you calculate A0 will be 0. There's just 3 elements and you have these 3 values. For A1 you'll get 1 element in this set. So this is the cardinality, which we write it as A0, A1, A2. So this is again 1. A3 is 1. And what will be A4? A4 will be 0. And so on. Everything will be 0 after this. N equals to 0 for all n greater than or equal to 4. Okay. So you have this.
One moment.
Okay. Now, what do we have now? So AX will be what? AX, generating function of A will be summation A and x raised to power n is equal to 0 to infinity. We'll get 0 plus x plus x square plus x cube plus 0 and 0 and 0. So this is just x plus x square plus x cube. This sequence class of A has the generating function to be equal to 1 by 1 minus x plus x square plus x cube. Okay. This is your answer. Yeah, fourth. Yeah, this is the answer. Okay. Let's move to the next question. A is a combinatorial class. Right, and the generating function of A is an x raised to power n summation this. Okay, power set of A of x is equal to summation n is equal to 0 to infinity bn x raised to power n. Okay, now which of the following is true? So yeah, now an is firstly, what is this? So you know that what is power set? Power set of A, again I'll write it as calligraphic A. So yeah, power set is set of finite subsets of A. Size of any such finite subset will be equal to all those alpha belongs to A. Alpha belongs to S, and you consider the size of that element. Okay. So this sum is your. The sum will define the size for this power set. Now, so now we need to compare An and Bn. Bn is this and An is this. An is for Ax and Bn corresponds to power set of A. Now Ax is what? Okay, let's see what is happening. So what is, for example, let's take An. An is what? An is the cardinality of the set all those alpha belongs to A, such that size of alpha in A is equal to n. Okay. So this is the definition. And again, for power set, what will be the case? You will have all the elements, beta, if you want to write, beta belongs to power set of A. So what can you write? You can actually write S to denote that, such that size of size of S in power set is n. Okay, so these are the definitions. Now what is this? So one observe that size of the singleton set alpha in power set is same as size of alpha in A, because this is just that sum. So you will have just that element alpha, and the summation will be just one summand. So you'll get this. This implies, so for every n, this implies for every n, this implies this set, this implies Bn will always, An will always going to be less. So you have this element always, and you have this element. So whatever values you will have for particular n here, you will also have in the power set. So this will be the bigger set, not a subset of the an set or anything else. So an is going to be less than or equal to bn for all n belongs to n. Wait, I hope this is clear. So this condition is true. So they asked is or are true, so there could be more. So okay, so I'm claiming that this is also true, this is also true. Try to find examples for these two things, which will be easy. You can just consider some suitable set, find counter examples. Okay, so for this one, for fourth one, claim is, so this is not something very typical. You can actually observe that. So what does this say? So for example, what is A0? Yeah, so you know what is Bn and these things, you know. So you know that the size n, so the size of the Bn is what? Bn, not Bn, size of any alpha, or you should write S, size of any element S in power set of A is equal to the sum of all those alpha belongs to S, such that size of alpha is A. Okay, so here what is happening, you are adding values. So you are adding values from this alpha. Now you observe that A0 corresponds to all those elements, such that all those elements, A0 is the cardinality of all those alpha, such that this is equal to 0. So, and similarly for A1, for A2, these are all. Now what is happening here? So okay, let's take an example, you'll understand that. So consider B1. So you have 2 raised to power A0 plus A. If we have to prove this. Now what is B1? B1 is all those elements from S, such that, like from power set, such that size of S is equal to, in power set, is equal to 1. Now this value is 1. So now what we are looking at, we will consider all those elements which have, so this is so power set is what? Power set is something, you have some set 1 to n. Now all the subsets of this set, so what you can choose whether one can be in the set. So if you consider any set, so if you consider any set, let S be a subset of n, then what will happen? Then S, the cardinality of S, so no, not the cardinality, then S could be, or maybe then set of, or maybe then S could be from any of 2 raised to power n possibilities, right? So you know that how many elements are in the power set. So 1 could be there, so 1 has possibility, like either it could be there or not, okay, not there. So there are 2 options for every element, so that's why you have to 2 raised to, so you have 2 options for this, 2 options for this, for all the elements. So you have this, okay, 2 raised to power n possibility. This is the way you get the cardinality of power set. So this is the same trick we are doing here. So in the sum, so you know that A0 correspond to all the elements which have size to be 0 in A, and similarly A1 is all the elements which have size to be equal to 1. Okay, now all those elements, so you have total A0 plus A1 elements which have size 0 or 1 in A. Now you pick those elements, so you have okay, pick elements from this, then total options we could have for the size of S, for the size of S in Port set of A. Okay, for the size of S in Port set of A, we could only have so 2 raised to power, or if you want, better to write for the subsets, for a subset of A with possible elements correspond to 0 or 1 size elements in A. So you have so there are total number of these many numbers which have size 0, these many numbers which have size 1. So you have 2 raised to power A0 plus A1 possibilities for S to have elements of size 0 or 1. Why we are looking at it? Because we are calculating B1. So B1, for B1, now you know that sum cannot go beyond 1. So we want, this is the sum of all those alpha, alpha belongs to S. So we cannot go beyond 1 and we want it to be 1. So we can only have options to be 0 or 1. So that's why we are just looking at these elements. So similarly you can get Bn to be less than or equal to 2 raised to power a0 plus a1 up to and so on. Okay, so this is the biggest bound you could have. Like this is not a strict and this is not a bound which can be which can always be attained. So this is a root bound. Okay, let's move to the next question then. For a binary tree with 10 leaves, so this you have actually seen from the notes, total number of nodes. So you have a binary tree. So binary tree is something which have either two nodes coming out of it, 2 leaves, or 0. Okay, so total number of nodes is equal to number of internal nodes plus number of leaves, right? So internal nodes are with children and number of leaves are without children. So this will be, and for binary, you know that number of internal nodes is number of leaves minus 1 plus this is number of leaves, and this should be 10 minus 1 and this is 10, so this is 19. So this you can check from the notes and pretty easy thing. So yeah. Okay, let's move to the next question now. What is the number of plane trees with 5 nodes? So yeah, okay, so you have, this is something, you have 5 nodes. So how many trees you can construct? So for plane trees, you have trees with a specific order. So for example, you have one, so you just try with a pattern. So you have 1 2 3 4 5. Third, what can you take? You have 1 2, and here what can you modify? You can just go this, and yeah, or you can have this, you can have this. So you have this. Now what can you do? So you take this 2 and you take 2 here. Okay, similarly go on and try to find all the brain trees. Okay, exercise. So just try to find all the plane trees. Okay, so you just need to do the specific thing and how many can you get, and this order thing you should maintain, because so if you have, for example, this and you have this and this, then this however you like it. So are different. Okay, as plane trees. That is the catch here. So just try to find all the plane trees you can have in 5 notes. Okay, let's move to the next question then. Okay, so a ternary tree is a plain tree with every node has 0 or so. Now you have the condition that every node can have either three childrens or 0 childrens. So yeah, this is same as binary, but for binary you can have 0 or 2. Now you have 0 or 3. So what will be the generating function? So again, similar to binary case, we know we have so let's like ternary, maybe this, I don't know, ternary this is isomorphic to, maybe if you want to write, okay, ternary, this is isomorphic to, you have this node, so you have this neutral class, and sorry, this is plus, and you take cross, and you have you take this square, now not this square, you take cube. So what you are doing, you consider this node, okay, so this is your main node, so this is your root, this is from the root, you take this one, so this chain and this chain, so these 3 will come for this, and this corresponds to the root for that, and yeah, so we have this, so this implies so tx is equal to, what will you have, 1 plus x tx cube. Okay, so this is similar to binary case, and we are done. Okay, yeah, this corresponds to this corresponds to this, and we are done. So I hope this is clear, and this was the last question from the assignment. Okay, thank you.